recorded as well. Okay, so measurement techniques, this particular topic is not going to help you, not only going to help you in theory, but it'll also be very much useful for you when you attempt your practicals, okay? Because there's a lot of techniques that we're going to study in terms of measurements, in terms of observation taking, when it comes to practical experiments, physical quantities, reading through different instruments. So this is majorly all that we're going to cover in this particular topic. So number one, when we talk about measurements, you need to generally have an idea as to what type of measurements are basically taken on which particular instruments. I'm sure you already know all of this, that length is generally either measured on rulers, vernier calipers, or micrometers. These are three major instruments that we use across the course of A-levels physics for measuring length. Weight on a balance, angles on a protractor, time intervals on a stopwatch or a calibrated oscilloscope, temperature on a thermometer, current on ammeters, voltage on voltmeters, small readings of voltmeters or currents on galvanometers, and magnetic field strengths on calibrated Hall probe. This is only the part of A2 level syllabus. But generally, these are basically the
For
instruments. Yes.
the measurement techniques, just the instruments specifically, would in MCQs would there be questions such as, okay, what's the difference between vernier caliper or micrometer?
Yes,
So if
definitely.
yes,
Yes.
so like could you be more specific for that? Vernier
Yeah,
caliper,
yeah,
micrometer especially.
yeah, of course. We're gonna talk about these in detail right after this. This is
Okay.
just this table is just to give you an idea as to what instruments we generally use. But again, yes, there can be questions on very specific usage of these as well. In which cases you want to use a ruler, in which cases you should be using a vernier caliper, right? So इसमें if we move on, number one, how do you pick up the appropriate instrument? It's very important for you to understand the type of quantity that you're measuring, all right? And number two, the recognizable change that there has to be in a particular reading for you to choose the appropriate instrument. If you talk about vernier calipers in detail, vernier calipers have a resolution of 0.1 mm. 0.1 mm is basically the minimum change that they can detect. ठीक है, जब हम resolution की बात करते हैं तो we essentially look at the minimum amount of change that the instrument can detect, which is basically it. And because of the resolution you pick up the appropriate instruments. A ruler has a resolution of 1 mm, right? Micrometer has a resolution of 0.01 mm. तो अब now 1 mm as compared to 0.1 mm, इसका मतलब ये है कि vernier calipers are more specific as compared to rulers. Now, if a minimum recognizable change is of 1 millimeters, you will obviously go for a ruler, or if obviously it's more than 1. If it's less than 1, if it's 0.1, 0.4, 0.5, you will go for a vernier caliper. If it's even less than 0.1, if it's 0.01, two decimal places pe, to pay you're going to be using a micrometer. Clear?
Yes.
Okay. So you look at the recognizable changes, you look at the resolutions when it comes to picking up the appropriate instrument. Okay, now this basically diagram helps you understand how a vernier caliper works. You don't obviously in your A levels physics, you won't have questions as to in your MCQ paper as to how a vernier caliper works, but it's important for you to understand because you never know in your practical exam you might be asked to use a vernier calipers. You should know how to use one. You should know how to read off a vernier caliper as well, because you never know this kind. Even in your paper number 5 for A2 level exam, which is planning, analysis, and evaluation, in that paper you might come across certain questions that basically are about vernier calipers ka usage. So it's important for you to know. Okay, now how to use a vernier caliper? You look at the main scale reading first of all. This yellow one is the main scale and this blue one is the vernier scale. Now, if we look at the main scale pay, you will first of all mark the line that basically appears against the vernier scale. For example, that is basically marked below zero on the vernier scale. Up zero say onwards, these are all the values on a vernier scale. And there's only one line that basically sort of crosses the zero mark against the vernier scale. This is the small line. I'm gonna make annotations over here for you to understand. So this is the line over here, which is on the main scale, and this is the only line that crosses the zero Marcoli line on the Vernier scale. Do you get this? So
Yes.
you're gonna note this down. This is gonna be 12 mm. Okay, so you just note it. Now, the next thing that you will look at is any line on a vernier scale and a main scale that coincide, जो बिल्कुल align हो जाए एक दूसरे के साथ. So this is a line over here. You see this one that basically aligns perfectly with the line on the main scale. And this line, if you look now up for the second reading, you look at the Werner scale. 1, 2, 3, 4. So now this line is 0.4 mm. All right. Um, if you look at this one here. Up for you to understand, the first reading was 12, the second one was zero point 0.4. As a final reading, what you do is you add both of these readings. 12 plus zero point 0.4 is going to give you 12.4 mm, and this is the final vernier caliper reading that you have. Got it?
Okay.
Now, the first reading was of the main scale, the second reading was of the vernier scale, and the
Observer.
third final reading was the addition of both of these readings. Okay?
Okay.
So I just have to clear this all off. Hold on. Yeah. Now, when it comes to micrometers, the only difference over here is that their resolution is a bit high and it's to 0.01 mm. And usually, micrometers are used to measure the diameters or thickness of objects. अब diameters कैसे measure हो सकते हैं? For example, if you have like a pipe and आप उसका cross section देख रहे हो इस तरह से, what is the cross section like this? If this will be a circular cross section of a tube, of a pipe, of a wire that's very, very small, and the readings like are even in 0.01 mm की जो range में जा रही हो. तो फिर this diameter could be measured by using a micrometer. So this is where a micrometer is appropriate. Okay. Up, how do you you now this picture basically is of a micrometer. How do you use it? Let's sort of go over is key information. So what you do is you number one, you place the object between the jaw of the micrometer. This is the jaw, it's retractable. You revolve it, it closes off. यहाँ पे you can place the object, you can then close it off again. And then you have like two scales again over here. Okay, there's like a barrel scale and there's like a thimble scale. ठीक है? अब यहाँ पे, yeah, बस this is a barrel scale and this over here is a thimble scale. ठीक है? अब आप करते क्या हैं? The first thing that you do is you read the barrel scale by looking at the edge of the thimble scale, यानी यहाँ पे. At this particular point, which value of, of the barrel scale sort of appears in front of you, जो बिल्कुल आखिरी जो value होती है आपके पास. Okay?
Okay.
And अब इसमें आपने दोनों 1 2 3 4 सब, यानी you need to read even the lines above this horizontal line and the vertical lines below this horizontal line. So this is like the fourth millimeter mark which is over there, and the mark that you can see before thimble scale sort of covers it. So fourth millimeter mark, and then you see कि जी कौन सा mark from all of these sort of aligns with the horizontal line of your barrel scale, and that appears on the thimble scale. Okay.
So for barrel scale हम लोग ऐसे पढ़ेंगे ऊपर नीचे 1 2 3 4 and then
Mhm.
the one which aligns with the
Mhm.
thimble scale would be the final reading.
Yes, which is in
Okay.
this case again if you zoom in it's around 14.5 something, क्योंकि 15 तो ऊपर चला गया है, तो 14.5 वैल्यू
Yes.
ऐसी है जो कि यहाँ पर आपको अलाइन होती हुई नजर आती है. ठीक है. तो this is supposed to be your reading. अच्छा, इसमें ये है कि you can also for more precision, um, आप you can also obviously look at the I mean इसके ऊपर जो thimble scale की readings हैं वो अक्सर इस तरह होता है कि अलाइन नहीं हो रही होती, तो फिर आपको you'll always have to look at the closest one for that case. Okay, and then you may even have to add up in that case, ये जो barrel scale की reading है, you may have to add up that particular reading with the thimble scale reading to get a more precise answer. Okay,
Okay.
so but that's only in cases where these lines don't align together. अच्छा, अब वैसे तो इस की रीडिंग्स पे आपसे एएस फिजिक्स में कोई इस तरह का क्वेश्चन नहीं होता, बट अगेन you never know. It's important for you to understand. Okay, the next type of instrument is an oscilloscope. What is an oscilloscope? It basically shows you the values of current. If you look at these graphs over here, yeah, they are all these current values, and they're represented on an oscilloscope. Oscilloscope has a time-based setting. It gives you the vertical variations as well as the horizontal variations. If you just pick up this graph as an example, the alternating current graph, you have like a time-based setting. That time-based setting, for example, if there's time on the x-axis and there's current on the y-axis. Now you can look at the current with respect to time in this graph. For example, अगर हम ये कहते हैं जी आपकी जो time based setting है, it is set to each for example this block is of 1 centimeter, and your time based setting is set up to that 1 centimeter would represent 1 second. And for our vertical axis, the time-based setting maybe is that 1 centimeter would represent 2 amperes. So now just as a standard graph reading works, this tells you that on the horizontal axis, if this is 1 centimeter, so we have said that 1 centimeter is equal to 1 seconds. So this is going to be 1 second. This is going to be 2 seconds, 3 seconds, 4 seconds, 5, and 6 is the 6 seconds का मतलब ये है कि आपका this is where your half graph is basically what do you say, half time period just hoga, and 12 seconds would be the one complete time period because this is one complete wave, right?
Right.
um Also, then if you look at the y-axis over here, in case of y-axis, we've said that 1 centimeter represents 2 amperes. So 2, 4, 6, 8, 10 amperes is the amplitude of this graph. So this is just one way of understanding an oscilloscope. जिसमें there's always a time-based setting, and that time-based setting is for the horizontal axis. There's like an output voltage or current setting, which is for the vertical axis. और आप you can adjust both of these. First करो, अगर आप ये कहते हो कि नहीं, now 1 second is, now my 1 second will be 2 centimeters, तो आपका ग्राफ expand हो जाएगा because then it will cross this line, right? अगर आप कहते हो
Right.
नहीं, half a centimeter would be 1 second, तो graph might just shrink up. तो oscilloscope का the biggest advantage is that your graph can vary in shape as you change the time-based settings. You can adjust both of these settings. Same goes for the vertical axis as well. If you reduce the scale, so your graph would become shrunken vertically. And if you increase these settings, if you increase the gaps, your graph might just expand vertically. So this just goes to show that your values, your the shape of the graph, the form of the graph would change as you change the time-based settings. And this is one of the major advantages of using an oscilloscope. All right. अब इसमें हम y gain कहते हैं, which is like the movement on the y-axis, and हम x gain कहते हैं, which is the movement on the x-axis. Okay, base and y
Okay.
gain majorly. This is how you. These are the terminologies that you use when it comes to an oscilloscope. All right. This is all that I've explained. Now we're moving on to galvanometers. A galvanometer basically could be used as a voltmeter or as an ammeter. This is an advantage. Generally, I'm sure you know ammeters are used to measure currents and voltmeters are used to measure voltages. Whereas a galvanometer can be used as both an ammeter and a voltmeter. It depends on the usage. But it detects small electric currents. ठीक है, जब बहुत कम values हो, in that case you can use a galvanometer. Um, it gives very accurate measurements. This is one advantage of using a galvanometer. A real ammeter, basically, it does not have an infinite input resistance, but a galvanometer has an infinite resistance. यानी current तो बिल्कुल गुजर ही नहीं सकेगा वहां से. Similarly, a potential divider is basically a component that divides potentials. It is like it's either a movable wire और एनी वोल्ट मीटर जो कि कहीं पे दरमियान में प्लग्ड इन होता है, तो फिर इफ यू मूव इट, बिकॉज ऑफ इट्स रेजिस्टेंस, it only detects the current in that particular circuit where you sort of place it. So for example, if this flying lead is placed in this particular point, तो ये जो पूरी wire है, this is gonna be a part of your circuit, and the resistance of this wire L1 would be calculated within this entire circuit. As compared to this, if you try to, for example, place, इसको इधर आप place कर देते हैं, galvanometer इधर है, तो फिर only this chunk, this particular chunk till this point would be a part of your circuit. बिकॉज वोल्टमीटर इधर है, वो इसकी मेजरमेंट दे रहा है आपको. ओके.
Okay. तो अभी when the galvanometer is like connected to the जो L1 है and the flying lead, so then flying lead and the L1 जो पूरा red line है that is calculated.
नॉट द फ्लाइंग लीड, बिकॉज गैल्वेनोमीटर यहाँ पर है तो करंट तो यहाँ आएगा ही नहीं, करंट तो यहाँ से गुजर जाएगा.
Okay.
या बिकॉज देयर इज
ठीक
सो मच रेजिस्टेंस एट दिस पॉइंट, द करंट वुड टेक द शॉर्टेस्ट पाथ, राइट.
ठीक.
या. ओके. You can adjust the length of L1. You see, why do we use a galvanometer, or why do we use a potential divider? Because if let's say you have a standard resistor, आपको L1 दे दी गई है and you're asked to vary the resistance with respect to I mean the value of resistance that you require in your circuit. So अब इसमें what you can do here is you can move the flying lead and you can use any part of wire that you want. If you want more resistance, you'll just push this flying lead towards the right side. If you want lesser resistance, you will push it towards the left hand side. So it depends on the amount of resistance you need in your circuit. Okay. Okay, then there's a Hall probe. We're not gonna do Hall probes as of now because most of it will be covered when we do the A2 level syllabus, and you don't require this in your AS preparation. So we're gonna move on to the errors and uncertainties. Okay. So this next bit about errors and uncertainties is again about the errors in measurements, the uncertainties in measurements, because whatever measurement you take, there is always a chance of error, either systematic errors or random errors. Systematic errors are basically um, errors that are due to the fault of apparatus. For example, if you look at this over here, faults in apparatus or in the experimental methods, they're all systematic errors and they affect the accuracy of your experiments. Random errors, on the other hand, they are caused by differences in measurements. For example, if you, as an observer, as someone performing the experiment, has taken an incorrect reading, so then it would be a random error and it would affect the precision and not the accuracy. All right. You cannot get rid of all the random errors. You can just reduce the random errors. But as far as the systematic errors are concerned, you can get rid of systematic errors. अब ये कैसे हो सकता है? Assuming कि आपने, if you were performing an experiment and you sort of took an incorrect reading, you can reduce that. You can take multiple readings, like 5, 6 readings ली, average लिया, आपका error reduce हो गया, right? But if there is a systematic error, you will have to change the instrument. तो उसमें you can fix the error, but random error में you can just reduce it. Got it?
Okay.
So these are the major differences between random and systematic errors. Now, how do you reduce random errors? Number one, you can take at least 3 repeats. आप repeated readings ले लें, you calculate an average of it. You can use computers, data loggers, cameras to reduce human error. जो अक्सर ये होता है, experiments, for example, physics में किस तरह की experiments आती है? Drop a ball and note down the time. अच्छा, अब बॉल ड्रॉप की है तो बॉल कितनी जल्दी टच हो रही है, आपसे ये अंदाजा नहीं लगाया गया कि बॉल जिस टाइम पे टच करिए ग्राउंड को, मैंने स्टॉप वॉच ऑफ करनी है, तो इसलिए यूज अ कैमरा, स्लो मोशन में देख लें जिस टाइम पे टच हुआ है. तो अक्सर ह्यूमन एरर्स तो ये वाले ना कि हम लोग बहुत जो बहुत सेंसिटिव चेंजेस हैं वो डिटेक्ट नहीं कर सकते. तो फिर यू कैन यूज हेल्प ऑफ कंप्यूटर्स, डेटा लॉगर्स और कैमरास फॉर टू रिड्यूस दीज चांसेस ऑफ एरर्स. एंड देन यूजिंग मोर अप्रोप्रिएट इक्विपमेंट्स जिनका रेजोल्यूशन हाई हो, लाइक माइक्रोमीटर्स. ओके.
ठीक है.
So this is all about random errors and the reduction of errors. कि इन random errors को reduce कैसे किया जा सकता है. Again, अब इनमें से there is no error of this sort जो you can get rid of when it comes to random errors, because जो human error है, आप ह्यूमन अगर चेंज भी कर दें तो एरर तो वहीं पे रहेगा, क्योंकि ह्यूमन ह्यूमन एरर तो इट्स स्टैंडर्ड, राइट? जो जितनी हमारी सेंसिटिविटी टू सी टू ऑब्जर्व चेंजेस, इट्स ऑलमोस्ट द सेम फॉर एवरी पर्सन. तो दिस इज व्हाई यू कैन नॉट eliminate these errors. Now, systematic errors, on the other hand, when they affect the accuracy, it's either due to faults of apparatus or any experimental method अगर आपका खराब है. तो in this case, you can completely fix a systematic error by changing the instrument. For example, zero error. अगर आप अक्सर ये होता है वेट मशीन पे, अगर आप अपना वेट कर रहे हो, तो अगर वो मशीन जीरो से आगे हो पहले से निकल, तो आपका वेट ज्यादा आता है. तो आप क्या करते हैं, आप उसका जीरो करेक्ट कर देते हैं, उसको बिल्कुल जीरो से अलाइन करते हैं, फिर वेट करते हैं, वेट कम हो जाता है. तो इसका मतलब क्या है कि दिस दैट इज अ सिस्टमैटिक एरर एंड इट कैन बी फिक्स्ड. बट व्हाट इज अ पैरेलक्स एरर? पैरेलक्स एरर ऑन द अदर हैंड इज अ रैंडम एरर. पैरेलक्स एरर में ये होता है, अगर आप जैसे हैव यू सीन अ क्लॉक, तो बिल्कुल आपको राइट साइड से देख लो टाइम आपको ज्यादा नजर आ रहा होगा लेफ्ट की तरफ, लेफ्ट से देख लो टाइम कम नजर आ रहा होगा. तो और बिल्कुल सामने से क्लॉक को जाके देखें तो टाइम बिल्कुल ठीक नजर आएगा. तो दिस इज द पैरेलक्स एरर. ओके.
So like, what would be the difference between a paradox error and a random error?
Parallax error is a type of random error.
So then why isn't it just called a random error?
Because random error has different types. Parallax error is a random error. इसमें क्या नाम है, if let's say you're sort of turning off an instrument incorrectly, or if you're measuring that, if you're getting like a high value for time, so your lack of sensitivity is like a random error. ये तो different names है ना. अब जैसे zero error is the name of a systematic error which occurs in instruments. Now, if an instrument is malfunctioning, or if it's not working, or if it needs zero correction, so all of these are different types of systematic errors. Random systematic errors, so they are these broad categories, but then there are different types of errors that are further classified under these categories. Okay. Okay. Calibrate up. How do you reduce systematic errors? Calibration के problems हो जाते हैं बहुत दफा, कि यही जो वेट वाली मैंने आपको एग्जांपल दी थी, बैकग्राउंड रेडिएशन अक्सर इन द रेडिएशन एक्सपेरिमेंट्स, देयर इज ऑलवेज अ चांस ऑफ, देखो रेडिएशन एक्सपेरिमेंट्स में होता है कि जो जीएम ट्यूब है वो आपकी मेजर करी होती है रेडिएशन, अक्सर ये होता है बैकग्राउंड रेडिएशन आके रेडिएशन काउंट ज्यादा दे देती है, फिर आप क्या करें, फिर आप उसको बैकग्राउंड रेडिएशन को रिमूव करेंगे. मेनिस्कस लेवल्स आप गलत पढ़ लेते हैं अक्सर. इसकी बड़ी कॉमन एग्जांपल है जो, लेट मी जस्ट ड्रॉ इट ओवर हियर फॉर यू. सेकंड. For example, if let's say there's like a measuring cylinder and दिस इज लाइक द वाटर ओवर हियर. अब वाटर का अपर लोअर मेनिस्कस होता है, राइट? अगर आप उसको लोअर मेनिस्कस से पढ़ेंगे तो वैल्यू कम आएगी, अपर मेनिस्कस करेंगे तो वैल्यू ज्यादा आएगी. तो व्हाट्स बेस्ट इज टू रीड इट एट द, कीप योर आई ओवर हियर, या लोअर मेनिस्कस पे रख लें, एडवाइजेबल, क्योंकि अपर मेनिस्कस पे तो वैल्यू ज्यादा आएगी. तो यू सी दिस इज इंपॉर्टेंट. ये आपका एरर्स रिड्यूस कर देगा. तो खैर, ये आपकी सारी ये बातें हैं समझने वाली कि किस तरह से आप इनको रिड्यूस कर सकते हैं एरर्स. ओके. Precision and accuracy. We've studied that precision is affected by random errors and accuracy is affected by systematic errors. It's important for you to understand that precision basically refers to how consistent the measurements are. कितना close है measurements एक दूसरे से. Accurate value से कितना close है. Example. अगर आपकी एक आंसर आ रहा है 1, फिर आ रहा है 1.5, फिर आ रहा है 1.25, फिर आ रहा है 0.75, फिर आ रहा है 1.35. अब you see, और मैं कहता हूँ इसमें जो करेक्ट वैल्यू है 1.25 है. इसका मतलब है आपकी जो वैल्यूज हैं ये सारी करेक्ट वैल्यू के करीब हैं. 2.75 है, 1.35 है, 1.5 है. बट व्हाट इफ आई टेल यू दैट योर रीडिंग्स, द करेक्ट वैल्यू इज 1.25, but the answer that you're getting is 2, you're getting 1, you're getting 2.5. अब ये जो पहली एग्जांपल मैंने आपको दी है इसमें रीडिंग्स एक्यूरेट तो नहीं है, लेकिन they're precise, they're very close. In the second one, the readings are not accurate. They're deviating this mean value. 2 है, 2.5 है, 1 है. इसमें 1.75, 1.35, 1.5, very close. समझ आई बात?
Yes.
कि हो सकता है your readings might be accurate, but they may not be precise. And your readings may be precise, but they may not be accurate. Right? This can happen. So precision and accuracy are two different things. Accuracy is when a measurement is close to the true value. And precision is when the measurements are just consistent and they may not be close to the true value. That is not important, but they're consistent. Okay.
Okay.
Now, okay. अब हम आते हैं, अब इन सारी चीजों की वजह से अब अनसर्टेनिटी आ जाती है. Uncertainty of a measurement is basically because of these errors. Human errors हैं, फिर यहाँ पे fault of instruments हैं, ठीक है. So there's so many things that add up to uncertainty, और इसकी वजह से ये uncertainty instruments में आ जाती है. For example, फिर you see this is how we write uncertainty: 20 degrees plus minus 2 degrees. The chance of error, it's represented as a plus minus value. Now this means that if the answer of temperature is 20 degrees, it can be 18 or 22. -2 +2 दोनों आंसर्स हो सकते हैं. तो देयर कुड बी एन एरर, हो सकता है इंस्ट्रूमेंट का फॉल्ट हो या ऑब्जर्वेशन का फॉल्ट हो कि ये एरर आपका आ रहा है, एंड दिस इज हाउ द वैल्यूज कैन फ्लक्चुएट एज साइंटिफिक एक्सपेरिमेंट्स. इट इज इंपॉर्टेंट दैट यू राइट द अनसर्टेनिटीज विद द आंसर्स, बिकॉज ये आपको बताता है कि नोबडी कैन ऑब्वियसली गेट द एक्यूरेट वैल्यूज, बट this is the chance of fluctuation. All right.
Okay.
Now, absolute uncertainty, fractional uncertainty, percentage uncertainty, ये पता होना चाहिए. Absolute uncertainty ये होती है जो सभी ने पहले बताया कि जी इतना ऊपर नीचे हो सकता है. A fixed quantity, that if it's 7 volts तो 0.6 volts ऊपर भी हो सकता है, 0.6 volt नीचे भी हो सकता है, इससे ऊपर इससे नीचे ज्यादा नहीं होगा. यानी 7.6 से ऊपर वैल्यू नहीं जाएगी, 6.4 से नीचे नहीं जाएगी. Plus minus 0.6, this will be the answer. Fractional uncertainty is when uncertainty is represented as a fraction. 7 plus minus 3 over 35 volts. Like now the error is in form of a fraction. And similarly, for a percentage uncertainty, your error is in form of a percentage. It's 7 plus minus 8.6%. Now, if your answer is 7, you get an 8.6% of 7 and you add it. Okay, this will be the fluctuation beyond that. And 8.6% of 7 subtracted from 7, this will be the fluctuation below 7. समझ आई बात? क्या आप उसकी परसेंटेज
ठीक
निकालते
है.
हैं तो फ्लक्चुएशन की
Okay.
रहती है. अगर मैं आपको जल्दी करके बताऊं, 8.6%, लेट मी टेल यू, 8.6% अगर होगा, डिवाइड बाय 100 करें तो ये 0.086 इंटू 7, तो ये 0.6 ही बनेगा आंसर. 8.6% of 7 is 0.6. So up, instead of writing this, you can also write that the uncertainty is 7 plus minus 8.6%. Yani the value could be 0.6 volts more or less than the actual answer, that is 7. Got it?
Got it. Okay.
Okay. Now, one way of reducing percentage or fractional uncertainty is to get larger quantities. क्वांटिटी की मेजरमेंट जितनी ज्यादा होगी, आपकी फ्रैक्शनल और परसेंटेज अनसर्टेनिटी उतनी कम होगी. ऑलराइट. तो स्मॉलर क्वांटिटीज हैव मोर चांसेस ऑफ percentage and fractional uncertainties. Okay. um तो ये एक, दिस इज एन इम्पॉर्टेंट ऑब्जर्वेशन. अच्छा, अब ये होता है कि अक्सर, फॉर एग्जांपल, इफ यू डोंट नो कि हमने मेजरमेंट तो भी नहीं ली, इंस्ट्रूमेंट है हमारे पास, हाउ डू वी नो दैट how much uncertainty would one particular instrument give us? For example, if your instrument is like a thermometer, now your thermometer, you haven't taken any measurement as of now, but you think, okay, how much uncertainty would that thermometer give me? So you'll just look at the least count. Now, least count is basically the smallest division. A thermometer किस तरह से मेजर करता है? 1 2 3 डिग्रीज में, इससे लो नहीं जाता, 0.5 डिग्री में नहीं जाता. So 1 degree Celsius is the smallest division. So your error would automatically be the half of that least count. ये आपने देखना होता है कि अगर 1 डिग्री सेल्सियस है तो आपकी अनसर्टेनिटी वुड बी प्लस माइनस 0.5 डिग्रीज. नाउ वट एवर वैल्यू of thermometer of temperature you will get from a thermometer, you will write plus minus 0.5 ahead of it. So the takeaway here is कि what in the case of instruments, you don't have the values before that, you divide the least count by 2, and that is the error, and then you write it with the reading. Got it?
Okay. Yes. Okay.
तो सिमिलरली अगर यहाँ पे रूलर है उसमें +-1 है स्मॉलेस्ट डिवीजन, तो फिर आप उसको डिवाइड बाय 2 करोगे और अनसर्टेनिटी प्लस माइनस ये आ जाएगी 0.5।
ठीक है।
Acha. Absolute uncertainties, adding and subtracting absolute uncertainties. We're not going to start this today because this will get like a bit overwhelming for you. अगर मैंने इसको आज ही करा दिया, we're gonna like keep this particular topic for tomorrow. But now, um, I'll be sharing this document with you so you can give this a read to understand this in a better way now.